Lesson 12-4, Example 1. Our objective is to learn to find the theoretical probability. And theoretical probability, we've already talked about experimental probability, so let's talk about the difference between those two. You could think of theoretical probability as what should be. Sometimes you could refer to it as the mathematical probability. The experimental probability is your actual results. So what actually happens, what is. And one of the ways that you can use theoretical probability is when all of the outcomes have the same chance of occurring. This is called saying that all the outcomes are equally likely to happen. It's fair. Essentially, everything has an equal chance of happening, so we say that's fair. This would be an example on this spinner. This would be a fair and equally likely outcome because we have three different colors and they all take up the same portion of the spinner. So that spinner has an equal chance of landing on any of those three colors. As opposed to this spinner, where we have more colors, we have 5 colors there, but 2 of which are green. So not all the chances are the equally likely. Green has a greater chance, the spinner has a greater chance of landing on green than it does of red, yellow, or blue. So these would not be equally likely. This would not be considered a fair experiment or a fair outcome. So theoretical probability, how would we determine that? Well, here is sort of what we would do. And the theoretical probability is equal to the number of ways that an event can occur out of the total number of equally likely outcomes. So what does that mean? Because that seems really kind of confusing. So let's take a look at an example of what this actually means and what you do to actually use this information. Let's go back to our spinner up here. And let's say we want to know what is the probability of our spinner landing on green, and this is the green area right here. It may look a little yellow on your screen. So we're saying we want to know the probability of it landing on green. So probability of green, and that's going to be equal to the number of possible ways that it can land, possible different ways it can land on green out of the total possible outcomes. Well, our total possible outcomes, we could land on green, could land on red, could land on blue. There's 3 different outcomes that could happen. So there's 3 possible outcomes. And there's only one way it can land on green. This is the only area that's green. The other 2, we have a red area and a blue area. If it lands in one of these areas, we would not consider that landing on green. We would only consider it landing on green if it landed in this area. So then there's only one way to land on green. So one way for that event to happen. So we say the probability of it landing on green would be 1 out of 3. There's a 1 in 3 chance that it would land on green. Let's take a look at another example. And this would be what is the probability of rolling a number greater than 4 on a fair number cube? So here's our number cube. We have 1, 2, 3, 4, 5, and 6 on there. And we want to know if we can find that probability of a number greater than 4. So again, we're going to set up our ratio, and in this case our total possible outcomes. Well, if we roll this, we have a chance of rolling a 1, 2, 3, 4, 5, or 6. There's 6 possible outcomes. We're only wanting to know what's the probability of it landing on numbers greater than 4. Well, on this cube there's 2 numbers that are greater than 4. there's 5 and 6. And there's only one 5 and one 6 on this entire number cube. So there's only two different ways that you can get a number greater than 4. Two different events, either a 5 or a 6. So there's two possible ways. So we could say that there's a 2 out of 6 chance that you could land on a number greater than 4, or just like fraction, we can reduce that down to 1/3, and we would say that there is a 1 in 3 chance, 2 out of 6 chance, or 1 out of 3 chance. Those are equivalent probabilities.